Cool. Hey everyone, we're here with Daniel, Director of Research at Kedit. He'll be doing a talk on towards industry adoption of zero knowledge proofs. How do we build trust on the technology? And I'll let him take it from here.
Hi everyone, very happy to be here. Thank you to Sinjun and all the organizers, those even behind the scene with a hidden face that we don't know they were helping, but thanks to all. And thanks for inviting us and me to speak about ZKProof. We're very happy to be community partners of this event. My name is Daniel Benarroch, and I'm the Director of Research at Kedit, which is a company building privacy-enhancing solutions for data collaboration. And I'm also supporting the development of the ZKProof effort, helping with the organization and making sure that the effort moves forward. And today, I want to talk to you about sort of three main things. First, I want to explain to you a little bit what ZKProof is, in case you're not super familiar with the effort. I know there's a lot of people who haven't been in the workshops. I want to try to convince you why the standardization of zero-knowledge proofs is important, mainly to foster adoption of the technology. And I'm going to explain to you what we are doing at ZKProof in order to achieve this goal. I know that there's several people here who are way well familiar with ZKProof and are definitely very important contributors. So I'm sorry if this is somewhat redundant, but I hope you do get some important points out of this as well. So let's just sort of start with the basics. Our mission at ZKProof is really the following. I mean, we are an open initiative that seeks to mainstream zero-knowledge proofs through inclusive, community-driven standardization process. And what that means is essentially that we have a community that drives the decision-making of the effort, and it focuses on interoperability and security, which are sort of the two most important components of a standard for cryptography and software, right? This community and the effort is led by this steering committee. It's composed of top researchers in the field of cryptography. I'm sure you all know sort of some of the names. I don't know if any of them are here in the event. If so, well, thanks for your work. And you know, they actually represent many different branches of zero-knowledge proofs, right? Like we know that there are many ways of building protocols, and here you can find several of the sort of founders or main pushers of those branches, especially from a research perspective. I wanted to make sure I say thanks to all of our sponsors. We're very excited to work with all of our sponsors and our partners, those that are recurrent, the new ones. And we're very happy to see how this set of friends and partners of ZKProof grows every year. Just to kind of put it all together under this slide, you know, we have sort of three main goals at ZKProof. First of all, the vision of ZKProof is really to become an effort, to be an effort that is that supports the development of the industry in the long term, right? So we want to make sure that the zero-knowledge field develops properly throughout time. And the way we do it is through these three main efforts. First, we promote education. So we have the ZKProof community reference document, which is a community collaboration. Basically, around 70 people wrote this document. It's an 80-page document, and it serves as guidelines and reference. It could be seen as tutorial as well. I'll be talking about this a little bit more. We have a guest blog post. Sorry about that. A guest blog post called The Art of Zero Knowledge, in which we invite different experts to write about different topics, and it's been growing. We have so far 6 different blog posts. And we have an online webinar series that we use to sort of for more introductory sessions. Of course, we have dozens of recordings from different workshops. The second point is that we aim to support research. The way we do this is in order to sort of make sure that creating a standard doesn't hinder innovation. We want to encourage and support that research. So we bring different entities together, such as industry, academia, and government. And in that way, when they're sitting around the table, you get different kind of influences, right? So industry, people from the industry motivate researchers to work on the real world problems, right? Not the problems that the researchers think that they are the best there. We also sort of explore together the place of zero-knowledge proofs within different applications and other pet technology, right? Privacy-enhancing techniques. Now, all that being said, we support all kinds of community efforts and events as part of this, right? And finally, we aim to create standards, right, and guidelines. So we have a set of working groups that are active today that are producing community standards. So basically, the community came together and said, this is what we want to build as a standard first, and this is what is being done. And we partner with different standard bodies and publishing houses and different entities to promote the adoption of the standard, because what good can a standard be if it's not being used and adopted, right? So that's about that. And it really all comes together in the different workshops that we have. They become a catalyst. We had a first workshop in 2018 where we kicked off the effort. You may see your faces or familiar faces here. We had over 70 participants. Then we had our second ZKProof workshop where we doubled in participation. This was hosted at Berkeley last year in 2019. And here we already kicked off this idea of having proposals being submitted in order to become standards. We also had that year a community event with around 100 participants in Amsterdam. And this event was more focused for business and enterprise people. We really saw that there was a need for companies to know and learn about this technology and understand what was going on, where the other workshops, the annual workshops that we host, are very technical. And so we wanted to facilitate that for business people. And this year, we were supposed to host our third workshop in London, but we ended up doing it online, of course, like most events today. And it was a very successful event. We had over 300 participants. We spread out the event over 5 weeks in order to fit everybody, or every session we wanted to have. And it was a great success. So I'll be talking more about what the outcome of this workshop was in a second. And the question here really is kind of, how do we make this all work, right, to achieve this vision? So the answer is to foster adoption, right? And we need to take a step back first and understand why standards are important. And I don't know if you're familiar with standards, if you've ever worked with standards, but essentially standards can provide you these sort of four main ideas, right? It ensures the product safety or security and quality. It enables interoperability and communication, which is imperative for having a global adoption and a global ecosystem. They facilitate business interaction and market adoption because it can create sort of a line of trust that goes from the most technical to the least technical people. And it provides a catalyst for innovation to reach commercialization. If you do not have a standard, then the latest zero-knowledge scheme is going to be harder to be adopted than if you do have a standard and it builds and extends that standard. And of course, some examples, you may know many more, but they're everywhere, right? We live in a world where we need standards: food quality assurance, airplane safety, internet communication protocols, software compliance like ISO for cybersecurity and things like this. You have MP3 and all kinds of standards, right? I wouldn't go over all of them. But the main challenge really is to achieve all of these points in a way that we can establish trust in the technology, right? Because how do we do that, right? The goal is to ensure that those on the right, the integrators and clients who are less technical and do not have the technical knowledge will reach that trust level they need in order to sell their product and to implement or to use the zero-knowledge system in their product, right? So in an ideal world, it all starts with the academic researchers, right? Where they build the schemes. So it all starts there. And of course, I say ideal world because now this is a blurry line. You have a lot of people in industry, in companies, building these schemes, but in some sense, they are researchers, right? And they build the schemes who are, in theory, secure. And then the scientific community comes and does some kind of review of these schemes to make sure that the security holds, right? At the same time, they're transferring this line of quote unquote truth, that is the mathematical truth of why this is secure, right? And then, once you have this security assured, in some sense, the engineers and developers are in charge of transmitting that security in the actual code and the software that they built, right? I see Sidera said that some of us are researchers, engineers, and devs, and that's completely true. That's the case. There's blurred lines here, but in any case, it's good. It helps to see this framework, I think. And once the engineers and developers have implemented the schemes, you can see how the integrators now can sort of be more convinced and trust the technology without having to learn all the math by themselves, right? Because math is hard, right? So, I'm sure you're asking yourselves too, there are so many protocols and schemes, like how do you even start, right? Like what do you do first in order to create a standard and foster this adoption? Well, here the point is to sort of create the right focus. And the right focus here is really that we need to build the infrastructure that is going to allow us to use the technology in the future, right? Whenever it's more mature, maybe, whenever there is, it becomes more efficient, et cetera, et cetera. And so it sort of all starts from this base of the pyramid where, the scheme's security and terminology is established. And that's part of the infrastructure because people need to communicate. Then you have sort of the APIs and the domain-specific languages that need to be built. And these can also be adapted and be more generic, right? And that way, whatever is built on top is easy, doesn't have to be so impacted once the underlying scheme is changed. There are, of course, a set of frameworks that need to be developed for benchmarking, and there is a huge trade-off space in the zero-knowledge field. I mean, it's quite amazing how it's so hard to create an apples-to-apples comparison between two different schemes. There is sort of the idea of formats and interoperability, because if you don't have interoperability as much as now, for example, the blockchains are very focused on their own systems, you do start seeing some interoperability and cross-blockchain applications and things like this. And it's important to have that interoperability. And of course, at the top, you have sort of these applications, but I want to say that you want to build applications in a modular way, right? For example, if you think about, the impact that the sapling protocol has had on the industry, it's partly based on the fact that used across different applications. And that's sort of what we want to aim to achieve, right, in the first phase, or quote unquote. So we've been really focusing on this and trying to build this for the past sort of 3 years. And we've gotten to a point where we have these two main processes at ZKProof. First is around the reference document. And as I said, the reference document is a community-wide collaboration. It serves as guidelines and reference of the state of the art. So I'll be focusing on this in a second as well. We have an editorial process for this document. So it is a live document. It keeps changing from year to year. And we definitely see a lot of traction from it, more and more. We are currently taking contributions. So I'll definitely, I'll be sharing, hopefully, these slides with everyone. So you can go ahead and check out the reference document. Please go ahead, review it. If you have any edits or additions you would like to make, that would be awesome. We suddenly have a translation to Chinese, which is kind of awesome. And so again, this action item, it would be great if you guys, if you all took some time, then we would really appreciate it. And the second process that I will be talking about is the idea of working groups, where the working groups are used to create the community standards, right? So first, the working groups derive from submissions to the workshops, to the annual workshops. And the working groups that exist today really come from the third workshop. There are 12 of them. The three that are most active today, I can't talk about every one of them, but the three that are most active are sort of these three: ZK Interface, Commit and Prove, and Encrypt and Prove, and Snark-friendly primitives. So I'll talk about the three of them. I want to give you a gist of it in a minute. And again, another action item, if you want to take something from this, please do join the working groups and encourage everybody to kind of achieve the stated goals. You can definitely follow the progress in this link. So for the reference document, we really have like two main goals, right? You can either be a consumer or a contributor of the reference document. If you're a consumer, you could be a learner because you're onboarding yourself into the field. You want to use some applications and you don't know really where to start to research. And this is a really good reference and resource. You are a mentor, so you maybe are a professor or manager, and you want to suggest some material for reading or for guidance. And you can be an evaluator, which you want to just check that a system that you're going to use in production is secure and sort of maintained against the state of the art, right? Or you can be a contributor and really say, I'm the innovator and I want to make sure that my research reaches the most amount of people. So, I'm going to integrate parts of my paper into this document. And of course, the highest sort of level here would be like if you become a sage, then, you can definitely convey all your knowledge that you've accumulated throughout the years and all the recommendations and whatnot. So I just wanted to say thank you to all of the contributors. This is a sort of list, an unstructured list, or at least there is a weird structure, to everyone who puts some time into this document. This is really a fantastic outcome of the effort. I want to also thank Luis Brandao from the National Institute of Standards and Technology of the US, who's been the main editor of the document and pushing for making sure that this document advances at the right pace. So if you want to contribute, please just email us at editors@zkproof.org. And we will definitely be happy to talk to you about it. So let's dive a little bit more on the actual standards and working groups. So I will start by talking about the Commit and Prove and Encrypt and Prove. Okay. You may be familiar with these concepts, but I'm going to take some time to just explain it for a second. The Commit and Prove and Encrypt are basically kind of two specific instantiations of a more generic concept, which is the idea of separating proof statements that are usable, right? So you have a commitment and you want to prove that the, okay, so let me maybe say something important in case you don't know, where if you're proving something on some data, right, you also need to prove the integrity of that data. And the way that it's usually done, and the best practice, is to have a commitment to that data, and that way you kept the private data secret, and you have a reference to that commitment somewhere, right? That's also why blockchains can be so useful. And now you're saying, okay, I have to prove that some data is valid under some commitment, but I also need to prove something about this data, right? What if I have the data, 2 years before I have the actual statement that I want to prove on this data? So the premise of Commit and Prove is that you can actually commit to this data at some point in time with some scheme, and then at some other point in time, you can just reuse that scheme in the proof without actually having to kind of reprove the commitment is integral, right? So you have sort of these two different proofs, right? And this is important because it gives you sort of the separation of concerns. You can commit or encrypt independently of the proof. It gives you a modular way of composing proofs, right? You can have one commitment and that sort of proof for that commitment, and then several proofs for different statements, and that they will all work together, right? You wouldn't have to reprove that you use the correct data for the different proofs. And it gives, at the high level, it can give some API flexibility, right? If you think about implementing this, well, you can replace the underlying proving system at ease in some sense, where you can and reuse the old commitment or encryption, right? And so just to say that these two schemes were actually two different proposals at the third workshop. But it was decided through the discussions that we had that we would put them together, we would join them and create a one overarching topic or concept, right? And so encrypt and prove is kind of that same idea in terms of modularity, but just with encryption. And so far, we've had sort of several milestones. First of all, the main proposal was actually a slightly different concept called encrypt with proof, which I'm not going to dive into the details, but you can feel free to go and check out the actual proposal at the documents, at the reference link that was given above. But we managed to actually kind of adapt it to this concept of encrypt and proof. And we're now writing up the encrypt and proof draft, sort of a proposed protocol in the draft standard. So every working group, I should have said this, and every working group has a charter that defines the goals and the milestones of that working group with a very specific and concrete scope, and a standard draft, right? Which is a little bit different from an actual paper. I don't know if you've ever read a standard, but it's just so that there can be that kind of specification written. Now, another milestone we aim to do in the coming week or two is actually to set up a call for comments and adoption, because now that we have sort of these concepts really laid out, we want to make sure that people are going to use it and get their feedback to see where it's going to be most useful, right? And finally, we want to make sure we seek adoption and follow up with sort of an API standard or the reference implementation, which is also being worked on. You can join this working group, by the way, by joining this Telegram group. Of course, it gets very technical. We encourage everyone to join. But just please be respectful in the best possible way. The next working group I want to share a little bit about is ZK Interface, which is actually a tool for interoperability. So if you're familiar with how zero-knowledge systems work at an implementation level, you have sort of two different components of the software. One is called the front end, which is exactly what actually produces what is called the statement, right? You write the constraints. You may be familiar with the concept of R1CS, right? So R1CS is generated by a front end. Here you have several front ends. In green, it's those front ends and back ends that are implemented with ZK Interface. And back ends are really the proving system, right? You have the math doing the proof computation on data, right? And the verifier. And so what ZK Interface allows you is to say, okay, I'm going to be using, say, Bellman, the gadget library of Bellman, the framework, as my front end, because I really like how you write it. But I actually want to use bullet proofs to generate my proofs. So in a world without ZK Interface, you would actually have to write a map of connection, right? We've been building ZK Interface throughout these last couple of years, and since last workshop, the working group has been improving sort of the different tooling that exists, and it provides sort of this communication framework between, right, as an infrastructure between components of zero-knowledge systems. It can get easy to write circuits by composing existing gadgets. So, for example, if you're writing in Bellman, but suddenly you need some sub-circuit or some gadget from Socrates or Mir, then you can take it in and just call it through ZK Interface. And really, it also minimizes integration and maintenance, right? If you're going to change some system like bulletproofs to Zexy, then you can use it easily through ZK Interface. And again, the milestones really here are that we've been working to support circuits, not just R1CS, but actual arithmetic and Boolean circuits. We are providing a reference implementation of tools, so we validate that the statement is correct, et cetera, et cetera. We have continued adoption, right, of ZK Interface. You see that we have still many software components to work on. And again, we want to create a call for comments, right, in this context. And the last working group that I would like to talk about quickly is these Snark-friendly primitives. Here, really the point is that when you use zero-knowledge systems, you're going to be inclined to use different cryptographic primitives in your application, right? And really, they are used all over, right? Like if you want to compute a hash function, a Merkle tree, a commitment, PRF, or some signature scheme, et cetera, these happen to be in basically every application of zero knowledge today. And it can be a challenge, especially when you want to compose these things. If you want to use a commitment and then that data goes into some hash, et cetera, when you're building these constraints or these circuits, it can be really confusing if you don't have the correct expertise. So we want to make sure that there is a standard around it. And this really will enable reusability, right? Like I gave the example of sapling before, really building on that. The homomorphic commitments of sapling have been reused all over, right? And really that is actually the basis of the working group standard draft. Some of the primitives that have been used in sapling are the basis for this document. And I want to give a special thanks to Dara there, because she's also leading this working group. I should have said thanks to many people. If you're working on this working group, you should identify yourself, and I will say thanks in the name of all. We want to essentially finish this draft, because there are still several primitives that are not done. And we want to test this draft with different teams, right? There's a lot of people working on, improved hash functions in terms of efficiency in the especially blockchain space and so on. So we want to make sure that the standards are going to be used. Finally, this is sort of just a picture of the other working groups that exist. So we're actually scheduling calls for the different working groups, and you should let me know if you're interested in joining them. We have different applications and again a benchmarking framework and different format interoperability. So you can see that really there's a lot of request and interest to create standards. With that, I will sort of close and say that we are now actually planning our 4th workshop. It's going to be, again, a home edition. Wait, you have no sound? Do you all hear me? I just read through the chat a second.
Yeah, we can hear you.
Yeah? Okay, good. Sorry about that. And so just to finalize, basically, we have in April 19th and 29th, we're going to have the 2nd edition of the home edition online workshop. So you should definitely save the date. And if you want to get involved and contact us, follow us on Twitter, etc., please do so. Now, I'm happy to take any questions. Thank you all for listening. Okay, let me see. There's questions here. Can you share the ZKProof Telegram channel here? Yes, I'll put the slides in a second, so you can do it. Okay, so Dara says, it seems as though Plonk is gaining traction as more efficient arithmetization. With Plonk itself, Halo 2 and Pickles all using it. Has there been any work on supporting that in ZK Interface? That's a very good question. We've been really going around the concept of custom gates, because I think the actual extension we've built for arithmetic circuits may actually be extensible to the Plonk version of arithmetization, which will support custom gates, which is essentially the main or best, most efficient way of building and using these constraint systems. So I hope that answers the question. And we are talking to Ariel and Zach. Okay. Any other questions? I guess I don't see any of that. Okay. So thank you all. This was great. Thank you for having me.
Okay, awesome. So we're going to transition to our next talk now. Thanks so much.